Hello everybody, thank you for tuning in. My name is Eduardo and I'm here bringing you content in a new exciting format. It's my first time doing a video presentation, so please hit the like button and subscribe. Today I'm here to talk about automating API client generation. It's a talk I have given on CTJS conference and React Advanced London meetups over the past few months, and I felt that we never have time to go in depth onto the demo because of the limitation of the constraints of the time that the presentation have. So I decided to create this video to present you a little bit more about the example of the library that I have, the project that I have created to demo how you can use Orval and how you can use packages to leverage your way to shift less in the way you build clients. Let's start by sharing who I am. So my name is, as I mentioned, Eduardo. I've been working on the front end for over 15 years. I've been building content on my blog since 2016, and I've been running mentorings over the past 2 years. So if you are interested in talking to me about technology, these particular presentations, or you wanted to connect to talk about board games, gardening, or any subjects, feel free to drop an invite on LinkedIn, and I will be excited to talk to you. So how this project is being structured is it has 4 packages. The first package represents an API, which I love personally docs. So I decided to create a docs REST API, which for simplicity, we fetch the data from the cloud, from another API, but you can do a database or you can do whatever system. The important thing is that this API will give us information about the different docs and breeds available, and it will ship that information to the different client. So how we do that is we take the schema generated by this API, we package together with an npm package, and we ship that package to the different consumers. In this case, we have created Next.js applications and a beta applications as an example, but you can have your native device, your mobile device, etc. Sometimes you can use technology like Svelte, Vue.js, React. So I choose React because it's the one that I'm most familiar with it, but you can use any of the technologies that the library allows you to do, and this is applicable to any of the solutions out there. So let's talk about a little bit about how the server is structured, right? So we get that data from the client, from the clouds, and then we send that data from the cloud to the consumers. But what we have as part of that setup, we have a way to generate the schema of the API, which I'm gonna show you in a minute. So that's the part of the server. And here we have basically the NestJS API hooks package. So as we can see, we will have a schema that will represent the representation of the API, which is the contract between the API and the consumers. Then what we're gonna do is we're gonna use the Orval client for this one. You might be using other ones, you can use any one, but the goal is translate this schema that is represented as a JSON file into a series of files that will contain the types that we need for running our application, the hooks that we need for actually fetching the data, and all the other elements that are really cool from the library that you can use to make sure it stays safe, that it's simple to access the data and send the data back to the API, etc., etc. And then we will have the consumers that will actually import that package and they will be able to use. And just to go a little bit more in depth of how it's been structured, as I mentioned, you have basically the backend of the cloud on a third-party provider. Then we have the API that is written in Next.js, and then we have basically the docs and the model that contain the types and the interfaces to fetch the data, and then a small provider that will allow us to instantiate the ReactQuery client to be able to share and cache all the information that comes back and forward from the package that we are importing. So now let's go into the project. So let me switch the camera quickly and then go into the project itself, right? So as we have here, we have basically the different endpoints. I don't know how familiar you are with Next.js, but this is how you declare within a controller. The controller will become the base of the import, which in this case is going to be a /doc. This is the external API that we have available for fetching the docs. And then we will have an endpoint called image that will have the image of a doc. And then we will have another endpoint of the breeds that this is the one that we're going to implement. So just to demo this on codes, so this is our schema. This is how a doc is represented, and this is how the information on the image is being received, right? So we have a specific URL that will contain the image, and pretty much simple, right? And this is how it will look like, right? So we will have a consumer that will render that beautiful docs, and we will be able to fetch. As we can see, this is the Next.js application, and this is the BT application. So going back to the code, so how we will actually have this available to us is basically through the consumer. So let me just quickly go here, right? So right now we have a Swagger schema that contains the doc image. Let me just make it a little bit bigger so it can be easier to see. So we have a dot image that contains that, which is part of the controller get image that will have a successful response, and it will have the dot image response. As we have seen on the visual element, all of pretty clear, pretty simple. So we can see here that we expect to be a success response status and a message with the specific dot image. This can be changed, but let's not worry too much about that. And from another side, we have what Orval have generated so far, which is basically a series of imports from ReactQuery that allow us to create those hooks and those fetchings, and as well a series of Axios calls, because I decided to use Axios in this context just to have another way of fetching things. And then we have what the doc image is, the data type that defines that. Obviously, this is a lot of codes and sometimes it might be a little bit hard to read, but I will walk you through in the most simple way. So first, you have the doc image. This is just a function to fetch the data. As you have normally on ReactQuery, you have basically a function that is the one that's going to trigger the fetch, and then you will have the hook that will handle everything. In this case, we can see that we fetch from localhost, which is okay. That URL can be customized and you can put a base URL, and that is actually part of the configuration. If we go to the Orval, we can change that specific configuration here, so we can actually change the base URL based on who is going to be the consumers, the environments, etc. So don't worry too much about that. That's just an example placeholder. The second thing that it does for us, it generates this query key that will allow us to manage the cache. Then it will actually manage to generate the auctions that are going to use for the query to cache informations, to manage cache invalidation, etc. As we can see, the different auctions are something I'm gonna skip for now, but as you can see, they are auctions really simple, which is about the query key, the different auctions on the types, etc., all a bit difficult to follow, but okay. So now what we see of interest of us is the hook created for a specific managing the use query. So it's the wrapper around ReactQuery. So when we talk about this, okay, if we go to the code, what we can see right now is this is the code being generated for the example that we are seeing for just fetching the image, as we can see here. On here, we can clearly see that they are a bit how ReactQuery is being used, or the best practice of ReactQuery. We have a specific function that will allow us to fetch the data and is responsible of just fetching the data in whatever format is done. Then it's a specific section that represents the query key. And then there is a series of functions here to initialize the query. So things like the types, the correct types to be used. We can see the query key that is expected to be used, which is the query key generated by the function above. The return types and the options that are going to be available for that. So just a bit of setup for actually provide the right types and align the types the way we want. I'm going to skip this part because it's a little bit about the same, but the interesting part is here. We have this use.controller get image, which is aligned with the specific naming that we have given to the Next.js. So this is customizable based on the specific value that we're giving here to the Swagger file. So you can change the way the operational ID is mapped. So you can find a different name if you think that name is a little bit convoluted. And then what we have is the interesting part. We have the query, we will have the series of options, and as part of those options, we will have here the specific function call to fetch the image, which is this particular function that will actually have the responsibility. And all of that is being generated automatically for us. And along the way, we have as well a series of mock that will allow us to mock the data, right? Along the side, we have a specific type for the doc, which is already populated for us as well, right? So all of that's done out of the box. So if now I go here to the Next.js project and add the new option, which is the option of the breeds, right? So, and I basically uncomment as well the specific entity declaration, which defines what a breed is. If we go here, we can see a breed is a series of definitions, which it can be an example of Kelpie, Boston, English, etc. Right? So just it's been defined by a specific record of a string that defines the top level breed and a subbreed of that one. So pretty much aligned with the format that we have, just for simplicity. So what I'm gonna do now is I'm gonna stop the server and I'm gonna basically run the generate package command for this specific document. And what this does for us is first is extract from the API definition the Swagger file, and secondly it will trigger the Orval generation. So now if I go back to the definition here on the OpenAPI hooks, we can see that the new breeds have been added from the controller declaration into the Swagger file, and from the Swagger file those have been processed and translated into create the different response types for the breeds and the different type definitions that we talk a little bit about on the schema. But interestingly enough, it has created for us the endpoint to fetch the breeds, and as well as we can see on the bottom, have created a specific hook for use query to be able to fetch those breeds, right? So it make really simple, really straightforward that we generate that for us. Now that we have all of this information available to us, right? So what we can do is we can publish this package, right? So what we can do here is now that we have the changes here, we can see that there are a bunch of changes. We can basically do the npm publish. Just for simplicity on this, let me just commit the changes before. Okay, so add breeds. Okay. Okay, and now we publish the package. There we go. No, good. So I have to comment the checks because we have examples on other packages. So just let me a second to actually set up to basically put the npm publishing. So what I'm doing now is publishing the package. So as simple as that. When this package is published, it will be available to us to basically be able to do that. So now we have published the package, Next.js 17, right? And that package is going to be available for us into the other projects, right? So now what we can do is npm update. Oops, sorry. I'm using PMP, so what we want is PMP update. It will fetch the latest version of the package that we just actually created. Obviously, there are other changes, but what we are interested on is this particular one, which is the 17th, which is the one is being fetched. Now, if we do run dev, right, after we have installed the package, and we go back here, there we go. Okay. So first of all, we can see that within the context of the API, basically after refreshing, we have the bridge, which is the endpoint that's been generated with Swagger and everything. And now from the point of view of the client, in this case, I've been fetching this one from the point of view of Bitter. So if we go to the consumer on Bitter, we can see that here I actually prepared it for us to simplify the demo. I simplify for us the ability to fetch this. We can see that now we have this endpoint available to us, and we can use that endpoint to display the bridge, right? So this is just code that is a boilerplate to be able to show that for us. So now we can see that all the bridges are available from that new endpoint that we have added to the new package version, right? That wasn't available before. And the same way we can do it for the consumer. If we go to the consumer, on the provider side, there we go. We actually uncomment this version, we uncomment this, and what we can see at the moment is it will tell us that the bridge is not available. So this is not a member that is available. And the reason because of that is because we haven't run the update here. So once we run the update, we will fetch the package. That new package will be available to us with the version 17. And if we basically are gonna just start the run dev quickly while we are showing. So now we can see that this new package is gonna be available to us, right? So now we see that this package is no longer a problem. And what we can do on this case is just uncomment the boilerplate code to basically showcase how the bridges are being populated on the Next.js application. So if now I go here, we can see that is now implemented. Now I refresh the page, right? And now the bridges have been fetched, right? So just to recap a little bit on all of the things I have done so far here, is the first thing is when you're building your application, you wanted to update the contract. In this example, I do it on the passive way, where the API will add the new controller and the new endpoint specifically, and that will generate the Swagger file. But ideally, you wanted to move it to the left. You generate the Swagger file, and that will be consumed by the server, and it will be consumed by the hooks. And then along the way, when I trigger a series of commands, in this particular context, as you can see, I trigger a command called generate package. That what it does is, first, it generates the Swagger file, as I mentioned, and second, it will trigger the Orval, with the configuration that we have, which is basically, it will move the generated information from the server into that package that we're gonna publish. Alongside, I will basically fetch that information from that Swagger file. So from that point, you basically have the hooks, then you publish those hooks through npm publish. That what it will do is it will update the patch version just for simplicity. It will commit the changes, and then it will make it available. So at that point, you just basically import the specific new version of the hooks, and you will be able to use it on that. So now that this is out of the way, so let me just quickly go back to the presentation after the demo. So one thing that we are gaining with this is first the type generation, that it will be available for us. Generally, when you are actually integrated with a REST API, you are forced yourself to be able to put manually the types or export the types somehow to make it then available. Technologies like TRPC, it does that for us, but when you have backends that are written in Python, Erlang, or other things, then it becomes a problem because it's no longer TypeScript on their side. Then you don't have an easy way to integrate with this. The second thing is something I haven't covered yet. You have the option to use SOT for form validation. That's available. It's just another option on the configuration of Orval. If you find interesting, drop me a comment and I will create another video how you will do that and how you will do the whole setup. The next thing is the fetching and caching. So it will provide you the actions in my case, because I decided to use it for simplicity, because maybe we wanted to import this into a server and fetch might not be available, but with the latest version of Node.js could be available. But just for universal kind of usage of this package, I decided to use action, which is widely known and widely used. Then I use ReactQuery, which will allow us for fetching. It automatically does caching for us by default, and as well does on error handling. I haven't gone into the details, but you go through the tab, you will actually see how this will be managed that way. So what we get out for free without have to do complex things is every time the API changes in any way, like new fields get added, things have changed, automatically that will trigger a new deployment. That new deployment will trigger a new package from the npm package. So you will have a version support automatically through the npm package semantic versioning. Something I would like to touch as well is, before I get into observability, is the testing tools. As I saw you earlier, it generates for us the MSW mocking functionality that will allow us to do the testing without have to worry about us setting up all the testing framework and everything manually, which is really great. So you don't have to do that when you wanted to test your endpoint in the context of the whole application. And then the final one, which is not in the last position, but is observability. Now that you have a package that is at the same level that the specific API that you're creating, you basically have a closer proximity for the people owning the code with the code that is being provided the client generated, right? Which is really interesting because it will allow you to do observability. You can check on the level of the package who is consuming that package. You can check as well in that package that is being imported who is importing those specific instances, those hooks, and you can actually use a mapping that this particular chain will affect these files, which will be in the ecosystem of this area, which will affect so many clients in this way. So because it's a package, you know, in the context of the import, much easier because people can add endpoints and hook in any way. So this way it's much easier for you to expose those specific changes and how that will impact the others, right? So finally, just to wrap things up, so one of the major key advantages we found for this was eliminate the risks, eliminate manual errors, because sometimes you introduce the ground validation, so the API specs some things, but you decide to create a subset of those things within your UI validation. It basically introduced the consistency between the backend and the front end through the contract, reduce the maintenance by reducing the number of bugs, because you don't write this code anymore. It's well tested, managed, and generated by a library with high level of confidence that will actually be able to replicate that process across many companies. And finally, it will allow the people from compliance to monitor better the package and be able to know what that package is using, how it's being used, what's the impact of that package, and create that audit trail on which version that specific bundle was generated with that one, and in a really compact way. And really, you can add new security criteria and new things when you're generating the client, and you can introduce more sophisticated rules that I haven't covered. And finally, the second part of the equation is it does have a big impact on cost reduction. It reduces the dev time by 20 to 30% because you don't have to write all those fetches manually. If you have multiple projects like React Native, Web Native, and then you have other ecosystem that you have a back office, you have a front end. So there are multiple projects that consumes that. You don't have to write over and over these particular hooks at that particular logic to fetch the data. It reduces the amount of code that you have to use on those projects, because that code gets generated for you and it will be separate on a specific package. So it's less information for people to understand and use. So make it easier to actually get projects. Faster feature development. As I said, this seems to be the same thing, the same topic, because you don't have to write it yourself. It doesn't actually need you to constantly be adding that boilerplate to do that. Performance gains here is actually productivity gains. So I will fix the slide. Conclusion. If you find this is interesting, what I feel is a motto for me is like set up once and use everywhere. If you have a back office CMS, you have a website and a React Native application, you can just set it up this one on the server once. Everyone will use those SDKs that will automatically be generated for you, and everything will be done for you. Thank you.